Hi everyone, and welcome to this lesson on AI-powered debugging. In this video, I will show you how to configure project-level instructions for GitHub Copilot, so that Copilot behaves like a senior Java developer who actually understands your project, not just a generic autocomplete engine. We will do that by creating a file inside our IntelliJ project. But before doing that, let's check if we have Copilot plugin installed. Click on Settings, find Plugins, and type Copilot. It is not installed yet in my case, so I will do that right now. Accept the notice and install. Okay, installation process is completed, so now we need to restart our IDE. As you can observe, we have a new icon on the right-hand side. To start using the assistant, we need to have an account in GitHub. I have the account, so I just need to sign in by choosing Continue with GitHub. I will authorize myself and click Continue. Then authorize GitHub and verify by email in my case. Okay, I type the code from my email and clicking Verify. Great, authentication successful. We can return to our IDE. GitHub Copilot is ready to use. Now let's create a file that we mentioned before. Right-click, New, File, .github/Copilot instructions md. Press Enter. You can add a file to a Git if you want. And here it is, our new file inside GitHub folder. This file will tell Copilot who it should be in this repository and how it should help me when I am debugging. Think of this as onboarding a new team member. Let me paste in a ready-to-use example, and then we will analyze it. Clicked on Editor and pasting the content. Let's quickly break this down. This tells Copilot to answer like someone who has strong Java experience and actually cares about code quality, not just about generating any code that compiles. This helps Copilot avoid suggesting outdated APIs or incompatible libraries. Next, we have a dedicated section when I ask for debugging help. Here we defined exactly how we want to Copilot to handle stack trace, how to explain the problem, and that we always want a JUnit 5 test that proves the fix. If the issue is related to Maven, suggest a command that could help us with finding a root cause of this issue. Finally, the general guidelines. We prioritize readability. We don't want Copilot to invent random APIs. And if it's not sure, we want to fall back to manual debugging steps in IntelliJ. Breakpoints, watches, evaluate expressions, and so on, instead of hallucinating a fix. Of course, you can modify instructions if you want and make your changes. Once you are happy with your instructions, you can commit this file to your repository. That way, everyone on your team gets the same AI behavior out of the box. From now, when you open Copilot chat in JetBrains and ask for help inside this project, Copilot will automatically apply these instructions on top of your prompt. So it should work even if the file is not open. In the next lessons, we will combine this with reusable debugging prompt files, so you don't have to retype long prompts every time. See you in the next lesson. Welcome in this lesson. Before moving on, let's summarize what we did in the previous lesson. We created one main global instructions file that Copilot always reads automatically. You can also create other instruction files. For example, you can set up rules for your test classes using the apply to keyword. Here are the examples from the official documentation. However, we will not cover this and just leave our single global instructions file. Okay, let's confirm that Copilot really reads our instructions file automatically. I will ask about that in the chat. I will close the file and open Copilot chat. Okay, let's see the answer. Great, we've got a confirmation that Copilot is aware of the file content. However, if you have some problems with reading the file by Copilot, please check the options, as maybe your IntelliJ version needs some adjustments. By default, it should be okay, and I didn't have to change anything regarding that. You can check the options here. Configure agents, and you see all the options related to GitHub Copilot, like instruction file locations and so on. By the way, global instructions file should be placed in the GitHub folder as we did. Other instruction files with specific rules defined in the apply to section by default should be placed in the GitHub and then in the instructions folder. Now, let's define prompts that you can reuse whenever you debug Java code with GitHub Copilot in IntelliJ. Instead of typing random questions into the chat, you will have a small set of prompts that consistently give you useful, focused debugging help. By default, Copilot reads our prompts from the prompts folder, so let's create that. New directory, prompts. First, our stack trace Sherlock. New file, stack trace md, and file content. Use this prompt when your console is full of stack trace noise and you are not sure where to start. To make this concrete, I will run basic debugging example main method from our project. As expected, we get a null pointer exception in the console. Okay, so let's ask for help. Okay, I will switch to agent mode, as in this case, Copilot can suggest code fixes directly in our project files. Now let's refer to our prompt and paste the stack trace. Okay, so what do we have here? Okay, we see that Copilot generated some tests. Let's verify the updated tests and check if they are working. So I will allow for checking that. We see the terminal, which was opened by Copilot. Okay, I will keep the tests. And let's see suggested fix. Okay, I will keep the changes and allow for running the command. After running the command in the terminal, Copilot wants to change something in our test, so I will keep the changes. Allow another time. Now we see the final version of the changes, which was also successfully verified by Copilot. We can run tests by ourselves to check if they are really successfully executed. And the whole class. Yeah, looks nice. And let's verify implemented change in our class. Okay, great. There is another error which exists on our developed branch intentionally in the project, but null pointer exception was fixed and tests added in a proper manner based on the prompt and the global instructions. We also see nice summary with all the details. Okay, let's move on to our second prompt. Next is the logic explainer. Let's create the prompt. And here is the prompt. Use this when the debugger stops inside a method and you are not completely sure how the data flows through it. We will use the real analyze object method from Java features example. I will copy the method and give to the chat. As you can see, if the method is highlighted in IntelliJ, then there is a reference to it, and we don't need to paste the method. Okay, let's create a new chat and provide our prompt. Now we have access to our prompt and to specific lines in the class where is our method. Let's send it. This time we used ask mode instead of agent and see that Copilot walked through the method line by line, calls out potential issues, and suggested where to put breakpoints. We see explanations for each case. Here are potential issues, suggested small improvements, and suggestions for the breakpoints. Let's repeat the question, but using agent mode this time. In similar way as we did for the first prompt, Copilot can implement suggested changes directly in the code and add new tests. This is like having a senior developer quickly reviewing the code logic with you. Okay, let's move to our third prompt. The third prompt is the modernizer. Use it when the code works, but it's hard to read and therefore hard to debug. We will use the original generate numbers method from basic debugging example. It has an intentional bug and uses rough types, which makes it a great target. Let's highlight the method and send the prompt. Using agent mode, as I'd like to apply the changes. Copilot finished the work, so let's review the proposed changes. We see that the for loop was replaced by the stream approach, but not only highlighted method was improved and changed, even though we referred only to the specific line of code where our method is defined. Besides that, Copilot tried to fix the errors and made the changes in the test classes. Because as we remember, we have a global instructions file that tells to create a test if there is a bug fix introduced. Okay, there is another test class that now contains the errors which were introduced by Copilot. Okay, so my final decision will be to undo the changes. Some changes were not reverted, so I will do that manually. Now there are no errors in this class. I will try one more time, but only for the generate numbers method. I hope that sentence will be enough for Copilot to focus only on our method. Okay, fine. This time the changes were limited to our single method and even our test class was not modified. Copilot refactored the code using more modern constructs. Now I will keep the changes. This example showed us that it's better to review the changes before blindly applying them, and if we want to refactor a specific method, then it should be better to clarify that in the chat or in our modernizer prompt. Okay, let's move to our next prompt. Welcome in this lesson. Before moving on to our next prompt, I'm going to commit current changes. This allows us to clearly see what was modified during this lesson. We don't necessarily need to push this to the remote repository right now, but committing creates a great snapshot of our progress. Now, let me fix a simple bug in the print array elements method of the basic debugging example class. Okay, let's say we have debugged our application, found this bug, and fixed it on our own, without using Copilot. In this case, Copilot only sees the current state of the class, so it's not aware of the previous code that contained the bug. For situations like this, let's create a regression test generation prompt where we can provide the git diff of our changes. As you can see, we are prompting Copilot to look for the exact changes in our code. Now, there are a few ways to get this information. Since we are using IntelliJ, we don't even need to touch the terminal or run git commands. We can easily pull everything right from the built-in local history. Let's do that. Right-click on the class, local history, show history. Then again, right-click and create patch. Now we can copy differences to clipboard or save in a file. If there are a lot of changes in the code, then I think file is a better option to not paste a long text in the Copilot chat. But for this case, I will copy to clipboard. Okay. Close the window and open Copilot. Now I will refer to our class and prompt, and pasting differences from the clipboard. Now we can send the prompt. Okay, Copilot finished the work. Let's check the results. This time, Copilot did exactly what we asked for, understood differences that we have provided. The old bug detection tests failed as expected, new regression tests passed successfully, and we have 8 comprehensive tests added by Copilot. All the new tests we see here, let's see if they can really be successfully executed. We can run them even now without accepting the changes. I will run all the tests from this class. We see interesting thing. The new tests pass, but the old one fail. And this is exactly what we wanted. Here is why. The new regression test passed because our code now works correctly. The old bug detection tests failed because they were specifically designed to expect a crash. Since our fix stopped the application from crashing, those tests now fail. It shows the test was accurate and our fix was successful. Now, when we are sure about the code generated by Copilot, we can accept the changes. Now we can move to our last prompt, the dependency detective. Before defining the prompt, we need to switch to demo runtime dependency conflict branch. Now we can create a prompt. Dependency detective empty, and here is the content. Use this prompt when having issues at runtime and you suspect a Maven dependency problem. This may include version conflicts, missing classes, missing methods, class path issues, or a dependency that works at compile time but fails at runtime. In our case, we will simulate a missing log bug dependency on the class path due to an incorrect Maven scope. As is typical with Maven dependency issues, we will not get a compile time error, but rather a runtime exception. Let's run the main method from advanced debugging example class. Now we'll use Copilot for resolving this issue. I will add the prompt and give some instructions. This instruction tells Copilot to use our prompt as the main instruction set and that our stack trace with the runtime error should be analyzed using the prompt as a reference. Now it's time for the stack trace. I will also add a reference to our POM XML file. Now we are ready to send the prompt. Okay, we can apply the changes as Copilot properly identified the root cause of the issue and changed the scope. Let's run the main method to confirm if now it's working fine. Same issue because we haven't recompiled the project. We need to do that and check again. Okay, perfect. It's working fine now. That was just a simple example, but I'm pretty sure you have experienced much more sophisticated issues. For instance, when you upgraded the Java versions in your project. This prompt will be a great starting point and will save you a lot of time when debugging dependency conflicts. Thank you for watching this lecture. Congratulations on wrapping up this section. We started with a global Copilot instructions file, then added focused prompt files. Together, they create a reusable AI-assisted debugging workflow inside IntelliJ IDEA. Instead of asking Copilot ambiguous questions, you now give it clear context and a clear task. That makes the answers more accurate, the fixes more practical, and the testing more reliable. Thanks for watching, and I hope that these tools make your debugging sessions faster and more effective.